taking a look at fractals. Fractals are kind of fun because you're looking at a pattern that exists within another pattern. And so as these go up multiple generations, you'll see how much more complex they get. Okay? One of the most famous, type of fractals is what's called the Mandelbrot fractal. Google that and you'll see, if you click on a video, you'll be able to see how intricate this thing goes, and it's kind of a little bit kind of interesting to watch. So let's look at the definition here. Fractal can be any structure that is self-similar, meaning it repeats itself when looking at it from closer scale. The image below is called a Sierpinski triangle. Notice that if you look at the entire image, you see a large triangle with missing triangles inside the larger one. If you focus on one corner of the triangle, you see an image looks like the entire image. So if we look at it fairly small, right, you see the main triangle here on the inside, and you see some holes here, and you even see some holes surrounding it there. When you zoom in super tight, you see in here almost a repetition of that same thing, where you have those triangles and then ones that are here and then additional ones. So that's an example of a fractal. Let's take a look at some patterns below, and we're going to go with both the recursive and explicit formulas for our pattern. So if I take a look at this first one, I see that I have 3 blocks. So I'm just going to put a 3 there. This configuration of like 1 block on top of 2 is repeated, and it's repeated 3 times. Here, here, and here. So if I take 3 plus 3 plus 3, I'm going to end up with 9 on that one. So now I'm going to take a look and see if I see any other patterns. Now I'm going to go bigger this time. If I look at this entire pattern, which kind of looks like a triangle made of blocks, I can see 1, 2, 3 of those. And we know each of those contains 9. So I can say this is 3 times 9, or 27. I could also look at how many of the little blocks there are. We'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're still going to have 9 blocks of 3 instead of 3 blocks of 9. So here we have a geometric sequence, but instead of our numbers, we have pictures instead. So if I gave you the number 3, 9, and 27, you would right away see that not only is a geometric sequence, but it has a ratio of 3, because to go from one to the next, I'm multiplying by 3. All right, let's go ahead and write our recursive and explicit formulas for these. I hope you remember these. So my recursive would be the easy one. So it's a to the n equals a to the n minus 1 times r, which would be 3. My explicit formula would be a to the n equals a1, which is 3, right? That's my first one. So a1 is 3 times r, and my r is also 3, to the n minus 1. And now it wants me to find the 10th term, and I'm going to have to grab my calculator here because I did not get this pre-done here for you. So a to the 10 is going to equal 3 times 3 to the power of 9, right? 10 is my n, so I'm going to subtract 1 from it, so it's going to be 3 to the 9. So if I have 3 to the 9 times 3, I get a value of 59,049. Okay, 3 to the 9th itself just gives me 19,683, but then multiplying that by 3, I get the 59,049. All right, let's take a look at this pattern. Here's another fractal pattern. And you're going to see patterns like this on your assessment. So you'll want to be able to recognize how you pick them out. So this first one has, I can see 1, 2, 3, 4 blocks. So this first one is a 4. And I can see a repeat of this shape several times in this next one. So 1, 2, 3, 4. So I have 4 of those ones that are 4 already. So 4 times 4 is 16. Now I'm going to look at this bigger pattern. It looks, I don't know, kind of like a lounge chair or something, or a sandal. So looking at this, I look at how many times I see that repeated. So I see that repeated once, twice, 3 times, and 4 times. So with 16 times 4, get 64. Okay, you could also run it as this pattern here, right? But you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you'd have 16 sets of 4 instead of 4 sets of 16. So getting from one to the other, if we wrote this down, 4, 16, 64. To get from one to the other, I multiplied by 4. So I know that my ratio for this is going to be 4. So let's go ahead and write our recursive and explicit equations. My recursive is going to be a to the n equals a to the n minus 1 times that ratio, which is 4. My explicit is going to be a to the n equals a1, which is 4, times my ratio, which is 4 to the n minus 1. Now it wants us to find it for the 10th term. So a to the 10 is going to equal 4 times 4 to the 9th. So 4 to the 9th is going to give me 262,144. I'm going to multiply that by 4, and I get a value of 1048576. That's just over 1 million. That would be a little bit harsh to try to find that in a pattern if I didn't have my equations. Okay, so the Koch snowflake is a fractal curve. So it's built by starting with a triangle. You remove the, you put another triangle on top of it. You remove the inside lines. So I'm going to show you how we're going to draw this. I am at a slight advantage because I am on this on an iPad so that I can get perfect triangles. So if I have a triangle and I start with it upside down, then I'm going to draw another triangle on top of this one. So at this point, I have 2 triangles. I'm going to take a little bit of time here and I'm going to clean up the inside of this so that I can get rid of those lines. So you may want to do this in pencil. I'm cleaning up those interior lines. Okay, so that's what I have so far. Then from there, what we do is we actually put additional, move this here. From there, I put additional triangles on the tips of the triangles, right? So I'm going to have a triangle there and a triangle there, triangle there, triangle there, triangle here, triangle there, and I'm going to put one on each tip. Then I'm going to go back in with my white, and I'm going to get rid of those little interior lines. So now it's starting to look like a snowflake. And I want to encourage you on this one also to go ahead and look up a, oh, hang on a second. I just completely, there we go. Look up this type of snowflake because they actually have videos of it being built and then the lines going away. And it's quite interesting how things go together. So this should be more like that. All right. And you can keep going and get additional sections, right? So the next step would be to put little triangles on top of those triangles, right? So that would be an additional generation of a snowflake. And of course, you would be getting those lines out, right? So it would look a little bit neater. Okay, so you can see how quickly this can get intricate. But this is an example of a snowflake pattern of a fractal. All right, so let's go ahead and have you pause the video right now. I want you to go ahead and see if you can find what these patterns are, what your ratio is for the geometric sequence, and do your explicit and your recursive formulas and find the term that it's asking for. Go ahead and pause, and when you're done, we'll check our work. Okay, welcome back. We're going to go ahead and take a look at our monitoring progress. Here I have one block. Here I have 4. Here I have a 4x4 grid, so that's 16. Here I have a 1, 2, 3, 4, 5, 6, 7, 8 by 8 grid, so that's 64. So I have a similar thing that what I had on the previous page, but the challenge is my initial number is a little different. So my explicit formula is a to the n equals a to the n minus 1 times 4, because that's my ratio. I multiplied by 4 each time to get the next number. My explicit formula is a to the n equals a1, which is 1, times my ratio, which is 4, to the n minus 1. So now we're looking for the 12th term. So that's going to be 1 times 4 to the 11. So if you go ahead and grab your calculators, we're going to get about 4 million on that one. Okay. Now let's go ahead and take a look at this one. Fractal pattern to write the recursive and explicit formula. Find the 11th term is what we want. Okay, so we've got 1 on this one. We have 5 of those. And then we have 5 groups of 5, so that's 25. Then we have 5 groups of 25, which is going to give me 125. So my ratio here, 1, 5, 25, 125, is 5. My A1, or my initial first term, is going to be 1. So my recursive formula is a to the n equals a to the n minus 1 times 5. My explicit formula, so this is recursive. My explicit is going to be a to the n equals 1, which is my first term, times 5 to the n minus 1. And if I find a to the 11, it's going to be 1 times 5 to the 10. So let's go ahead. I'm going to take a look at that in my calculator real quick. So 5 to the 10th is going to be 9765625. So about 9 million on that one. How'd you do on these? Hope you did well. You're going to see these types of questions on your assessment.